This is part 3 of section 5.2. We want to solve this system of equations. Now before I do this, I want to remind you of a couple of things. When we were working out these problems, the whole purpose of pairing 1 and 2 and 2 and 3 was to get two equations with the same two variables. So remember that, because we can use that to make this next problem shorter. So what we want to do is we want to solve this. This first equation is the thing that tells me I might be able to make this a little bit quicker because it is missing a y value. Okay, so I'm going to call this equation 1, I'm going to call this equation 2 and 3. Since I see that this only has 2, if I skip the step where I pair up 1 and 2, where I'd have to get rid of a z or something, and then I would have a y show up in my answer, and it's already missing. If I just skip that step where I pair up 1 and 2, and basically I treat this like 4, which is sort of like a bonus. I mean, we've already got one of our equations that only has two variables. And then if I take 2 and 3 and pair them up, and I get rid of y, then I will have x and z, and I can automatically pair that up with 1. Basically, because this first equation only has two variables, we get to skip this step. It's like they did this step for us, and then they took equation 4 and just replaced equation 1 with that. They just made it easier for us. Okay? So I'm going to skip to 2 and 3, and I want to get rid of y so that it matches equation 1. So this is a 2, this is a -1. They already have opposite signs, which is nice. And if I multiply equation 3 by a 2, then my y's are going to go away. So recopy equation 2, there's no change here. And then multiply equation 3 by a 2, and you get 4x minus 2y plus 2z is equal to 6. Now the y values are gone, and I have 5x plus z is equal to 7. I'm treating this one like 4, so I'll go ahead and call this one 5. And what we have done, we now have two equations, 4 and 5, with the same two variables. So now I pair up 4 and 5, which this is of course 1. And it looks like our z's are almost set up to cancel. It looks to me that if I multiply one of these two equations by a -1, my z's are going to go away. So I'm just going to multiply this one by a -1. So I got -x minus z is equal to -3, and recopy the other. Now add these together, and we get 4x is equal to 4. So our x value is 1. Now we want to take this value and plug it in someplace where we can find another one. I can plug it in here and find z, or even better, I can plug it in here, which was number 4, and find z. This one's easier because this doesn't have a multiplier. So I'm going to choose to plug in to equation number 4. And again, I could have done 5 at this step. And that gives me 1 plus z is equal to 3. So z is equal to 2. Okay, so I have now two variables. Now I need to find y. And normally at this step, we'd say you can plug into 1, 2, or 3. If you plug into 1, you're not going to find y. So in this step, in this particular variation of a normal system, we really want to plug into either 2 or 3 here. And since we're looking for y, it looks to me like maybe equation 3 will be easier. But I could have gone into 2. Okay, So this will give me, I'm plugging into 3. So 2 times 1 minus y plus z, which is 2, and that equals 3. So I have 2 minus y plus 2 is equal to 3. 4 minus y is equal to 3. Subtract 4, negative y is equal to negative 1. So y must equal positive 1. So your answer is the ordered triple. Again, always slow yourself down here. Don't be careless and write down the first one you got, the second one you got, and then the third one. It has to be x, y, z. So this is 1, 1, 2. And that would be your answer to that one. Okay. So this is another variation, and this is also easier than it looks. You'll notice that we do have 3 equations with 3 variables. It's just that no 2 equations have the same 2 variables. So I'm going to approach this like I did on the first page of the notes. I'm going to call these 1, 2, and 3. And I'm going to pair up 1 and 2 and get rid of a variable. Now the thing is here, I don't have a choice. The only variable 1 and 2 have in common is x, so I need to get rid of x. So let's just multiply the equation 2 by a negative 1, and that's going to give me an x and a negative x. So I have x plus y. I'm going to leave myself some space for the z equal to 4. And then negative x minus z is equal to negative 4. So this gives me the equation. Your x's cancel. You have y minus z is equal to 0. And this would be my equation number 4. Now my next step should be to pair up 2 and 3 and get rid of the same variable. But there's no x in both of them. This third equation doesn't have an x at all, which means I can't do that. So you need to step back at this point and ask yourself, well, what is it we were trying to do? Why do we pair up 1 and 2 and then 2 and 3? And that's because we want to have the same 2 variables in 2 equations. But again, just like up here where it's like they did part of the work for you, they did part of the work for you here as well. This I'm going to treat like 5. Because both of these have y and z in them. So if I pair up 3/5 with 4, I'll be able to get rid of a variable and go from there. So I'm going to pair up 4 and 5. And these are already set up for our z's to cancel, so we don't need to do any multiplying here. So 4 was y minus z equals 0. This one, y plus z is equal to 4. Z's cancel. 2y is equal to 4. So y must equal 2. We have one variable. We just need to plug in someplace that will give us another one. I could plug into 1 and find x. I can't plug into 2 because there's no y there. I could plug into 3 and find z. I could plug into 4 and find z. I'm going to go into 1. So I have x plus 2 equals 4. So x is also 2. Now we just need to find some place where we can find z, which means I can't plug in here because there's no z. Well, I could plug in, it's just not going to give me z. And then I could plug into 2 now because I have x. I can plug in here because I have y, and here because I have y. Let's just go into number 3. So that will be 2 plus z is equal to 4. So my z is also 2. Now this problem is very easy to check. All our values are 2, so all of these are 2 plus 2 equals 4. Absolutely easy to check. Your answer here is 2, 2, Now, I know that these problems aren't necessarily fun, but if you slow yourself down and you're very careful, they're not so bad. We are going to come back in a later chapter to systems of equations in 3 variables, and we're going to learn 2 more methods for solving these. And you'll probably end up with a favorite. Well, maybe not a favorite, but the one of the 3 that you like the best, even though you may not like any of them.